Thanks everyone for coming over. Also, again, really appreciate the support from EigenLayer and AWS for providing the office. And thanks for all our partners and speakers to contribute to this Unconference for TEs. So today I'm going to share more about our thought process of how we are able to provide or extend machine trust to Web3, like basically verifying some of the attestations on chain. To start with, I think, yeah, can you get some help to click the next page? So I will start with why DEs. I guess everyone in the room have enough context, so I won't be spending time on explaining what is DE. So why DEs? So of course, people have been talking about you have maybe integrities, confidentialities and integrities, but these things are more like attributes on the machine itself. So how are you able to verify it? So that comes to the question of this proof. So proof is difficult because like the machine are manufactured by others. Also the CPU chips are there multiple kind of private technologies. Each of these are like different chip manufacturers are doing. So what we are trying to do is really to find a way to make the trust more like permissionless. So that's why we're going to present this proof of machine code. It's essentially a way, decentralized manner for us to verify machines' identities, their attributes, make sure that this integrity and confidentiality properties are intact. So moving on, we're gonna have several layers going on. I think in general right now in the blockchain world, there are a lot of rollups going on. These rollups are shared kind of similar stack. They settle to Ethereum. They have their own execution layers. So our take here is we can actually establish proof of machine code on the rollups. That's also our current approach now. We have a rollup running. We'll be deploying smart contract that could directly verify some of the machine's identity, essentially verifying the key attestations. So actually, with the proof of machine code, we're able to provide something like T coprocessors. And why we're doing coprocessing? Because it's kind of the most important use case. Once you realize that the scalability is not like unlimited, you have rollups, but in the end, you might need other scaling solutions as well. So ZK is one of them. Probably you can also just run things in TE with like a lot lower cost. Of course, there will be some trust assumptions if you can accept those assumptions. So on the coprocessor, we actually have, I think right now there has been discussions around multi-proving for rollups. This is really a great use case because it actually balances like trade-offs between security and the trust assumptions. So the idea of like multi-proving or using TE prover for like multi-proving is we will just re-execute all the L2 states within the like TEs. Of course, your team probably have their own liquid proof running already. So this additional proof can serve multiple purposes. So for example, they could be used as maybe a fast finality if you want to show you that your transaction is already at least validated by the next TEs. Or you could just consolidate both proofs on chain so that eventually the final confirmation comes with like a lot more different technologies. That basically means defense in depth, so you don't have single point of failure. So on that, we actually work with Scroll and Linea. We're helping them to build the prover stack. But also we noticed that other teams are working on like similar stuff as well. I mean, Typo has their own stack. Even ZK recently just released their TE prover. We will be also working with them on the verification part. It's essentially the proof of machine code, so that their smart contract can directly verify their TEs, no matter what technology they're using. So there are a couple of advantages, of course. I won't be diving into the details here. Next, I want to mention that with the multi-prover, what we are thinking next step is how we are able to really run this in a decentralized manner. So our solution is to work with EigenLayer because by working with us, we can quickly just come up with a whole network of operators. It may help us to solve the bootstrap issue, bootstrap of the operator network, and bootstrap of some of the economic security that we need for constructing the whole network. So actually, this is the whole architecture. So I put it in down parameter because it has too many jargons here. But the one liner to explain this is we're trying to like allow multiple like different prover and different operators. We're using different stacks. Then we like match them with the supply, and we match them with the demand coming from the rollouts who needs this kind of multi-proving. So eventually, operators can just permanently join or leave the network. They will just get rewarded if they finish their proving work. So this is some of the tractions we're getting so far. I think at the moment, the multi-prover AWS is running on EigenLayer mainnet. We have over 14K different stakers. We have over 70 operators supporting us. Also, that actually contributes to contribute to this almost 1.8 million restake fees. Then also would love to like announce this as well. So we just released this collaboration with WorkCoin. We're actually helping them to put their MPC algorithms within the GPUs. Because nowadays GPUs has already supported the TE mode. It essentially creates kind of mutual bridge between the GPU card and the CPU, so that you can extend the trust boundary to the entire like GPU memory. That allows actually more computation. I mean, those kind of parallel computations to be done if you can utilize maybe CUDA. So this is just a start maybe for MPC with heavy computations, but the same stack can be used for a lot of like AI inference model as well. So then essentially you can have like maybe the model province basically means that if you can meet someone that you're running ChatGPT for, you can just verify it instead of just blindly giving it. So how to build on TEs? We actually thought about this previously because we really have to deliver solutions, and we tried multiple different technologies. But I would say that so far the most like ready to use out-of-box one are maybe Intel-based and maybe AMD-based. We're of course also trying AWS Nitro Enclaves. The CUDA support, I mean the GPU support from NVIDIA is at really like early stage. Maybe you can get access if you've got the card. Also, you have to like prepare the full setup. But what we're thinking about is we should really start like releasing like stacks, like code bases that enable developers to be able to develop their own applications. Also, we're actually releasing this decap attestation v4 library. This is a solidity implementation of the decap protocol. It supports both Intel SGX and TDX. So with this, you're able to get the code from your machine, then put it in a smart contract. So this contract could be running on our layer. You can also deploy it on other networks, so that eventually you will be able to verify your machine's like authenticity. Of course, along with this, we release on-chain DCCS. This is on-chain registry, also on-chain management for us to manage all the collaterals coming with Intel attestations. So we also work with RISC0 to develop this really like cheap, affordable verification method, so that you can use bonsai as a kind of alternative approach to verify the attestations. And on the native solution, we're actually working with Dashboards. They've been using this for their like experimenting with for their TDX for the swaps. So so the attestation is just like it creates a link between your enclave and the on-chain registry. Also, we've got a lot of like interest from partners because they now have interest on building their own solutions, maybe using Intel SGX. So that's why we're also open sourcing this SGX SDK. This SDK essentially allows you to like craft your first enclave with this like Rust-only like environment. So you could just put in other libraries, make sure it's no STD standard. Then you can just use Cargo to build everything up. I mean, we have very clear documentation here showing you how to actually construct an enclave, how to provide equal calls. So if you need help, just also reach out to us. We'll be happy to get feedback and also make improvement there. So a couple of use cases are also released along with SDK. We actually open source our prover previously, so that prover actually includes the implementation for Scroll and Mania. We also released this RDVM, like fully running in SGX. So you're able to also get a code, compile it, deploy it to some like maybe Intel SGX, then try to do the attestations fully on chain. So I think this is everything. I will just stop here, but please find us through all the social channels. Also, our team is here. If you have questions, feel free to ask us. Again, welcome everyone to the Unconference. Hope we have a wonderful afternoon for everyone. Thanks.